Well, I just wanted to make a quick note on libraries. So one of the reasons Python is so popular is because of the multitude of libraries that exist. So these are pieces of code, snippets of code, or functions that have been created by other users that have they've made those freely available for us. So a math function is a math library is a common one. In your next assignment, you're going to have a statistic. You're going to need to use the statistical library. So if I type in Python statistics library. So we have, so this is the library, and these are all various functions that exist within it. So let's imagine I want to find the, you know what? I'm going to just work with the math library instead. Because often statistics you need a lot of data, so I have to create lists to show it, whereas these functions just take one number. So I'm going to go with the math library, but I want to show you 3 different ways that we can import math. So one way is simply to say import. Oh my gosh, why does this keep happening when I'm recording my screen? Okay, import math. When I do that, it imports the entire math library and it makes it accessible. The nice thing about this is that should I have, if I decide to create some variable called ceiling, I can say this is equal to 12, and I can print ceiling, and that works out fine. But notice that inside of the math library, there is a function called ceiling. So if what that does is it returns the ceiling of x as a float, the smallest integer value greater than or equal to x. So it remember we had our floor division, which that was a // So if I print 11 floor division 2, that equals 5.5. 5.5 is halfway between 5 and 6, so it goes down to the floor, meaning it'll print the value 5. I run that, print. Floor division with two slashes, and it prints the 5. Ceiling, what that does is it does the opposite. It takes that division. 11 divided by 2 is 5.5, and so it goes up to the ceiling. It rounds up to the next integer. It should print a 6. Oh, and look at that. It doesn't understand what ceiling is because I've said that ceiling is the number 12. So how can I send ceiling as a variable in with this sending in parameters of 11 divided by 2? I can't. The way I need to access the library function called ceiling is I have to precede it with the math library, and I call it ceiling. So now this is now giving me access to the function called ceiling inside of the math library, and the function called ceiling requires that I send in a parameter, a float value, a number. The number I'm sending in is 11 divided by 2, which is 5.5. 5.5 gets sent to ceiling. Ceiling says go up to the next greatest integer, so it should go up to 6, and it recognizes that ceiling is a function because it's inside of the math library, which I have imported in line 1. So now I run it. The ceiling was 12. So ceiling here was 12. I stopped printing that, but it's still accessible. So it prints 12. The 11 divided by 2 is 5.5. It rises up to the next integer, it prints a 6, and floor division 11//2 brings it down to 5. So that's all well and good. And the nice thing about it is that I don't need to worry about what all the various function names are inside of math. Because if I take a look at math, there are, there's copy sign, fabs. Maybe I create a variable called my my fabulous sport, and I decide to call it the variable FABS. Well, now I could potentially have a conflict with the math library if I didn't have this ability to access, to differentiate the library function ceiling from the variable that I've declared here. So that's how we get around that, is by importing the library and then accessing the function call by preceding it with the library name, math.ceiling. But let's instead imagine that I'm going to be doing a lot of function calls to the math library. And every single time I do, I've got to precede it with the word math. That might be cumbersome. And I might rather be able just to use these names on their own, called ceiling, copy sign, fabs, without the word math. To do that, I can say from math import everything. What that will do is it will import now all of these functions. I'll have access to ceiling, copy sign, fabs, factorial, floor, fmon. I'll have access to all, and it just goes on and on. I'll have access to all of these without having to precede it by the word math. So let's take a look at what happens. Now, if I comment this out, if I print ceiling, let's watch what happens. It says built-in function, ceiling. It's saying I'm trying to print out what ceiling is, but ceiling is actually a function. It's letting me know it's a built-in function. The function is named ceiling, which is coming from math. That function is expecting that I send it a variable, that I send it a parameter, that I send in data into that function so that it can then return something. So now when I run this, it prints the number 6 as expected because 11 divided by 2 is 5.5. Ceiling raises it up to the 16. So recognize, however, that because I've imported everything from math, maybe I'm planning on using ceiling, but I may not know that there's a fabs thing. I might say fabs is equal to 12, print fabs, and it's done that. But I've also got the fact that, is it fabs? Yeah, fabs. I've also got this print fabs 2.5. Integer, I don't know what fabs takes. Fab, return the absolute value of x. Well, so that's it's giving us an issue because although fabs, what I've just done here is I've declared fabs as a variable inside of my program. Presumably, I should also have access to the fabs function from math dot fabs. So we're kind of getting unexpected results. We'll see the same thing with ceiling now. Let's just get rid of our fabs example. So now when I run ceiling, I'm getting an issue because I've said ceiling is equal to 12, but ceiling presumably is a function that I can do. If I run this, so by declaring it as a variable, it's now overwritten the functionability from the math. So when I import everything from a math library, you tend to potentially have problems in your code because of unexpected conflicts between variables or functions that perhaps you've declared yourself in your program and the functions that are built inside of a library. So importing everything potentially has some issues. The other thing I'm told is that by importing everything, you're kind of bloating your code because it now I think it takes up more memory because it now has accessed every single function built within inside of a library. And some libraries may be massive. So if instead, so the from math import everything, so from library import all the function calls, that allows us to access. Right now, if I haven't declared what fabs is, if I now say print fabs -5, that works. It's giving me the absolute value. But if instead what I think, well, I am going to be using an awful lot, I am going to be using this ceiling function a lot in my program. I want to be able to access ceiling as a function on its own without having to precede math. What you can do is you can import a specific function. So you can say from math, import ceiling. And now I still can access, yeah, look at that. It doesn't recognize what math.ceiling is because I've said ceiling is now a function that stands on its own. So I need to simply call ceiling as its own function and I run it. Did that? Okay. So it's printing out the 6, 11, floor division 2. It's not recognizing what fabs is because fabs is still a function inside of math and I've not specifically imported fabs. If I run that, still doesn't work because the only thing I've imported is ceiling. So finally, if I want this to work, I can import both ceiling and fabs. So now from math, import ceiling and fabs. I now have access to both of these All right, so that's